This is Dr.D Govardhan, Professor in Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today the topic is central gravity of bodies, that is three-dimensional object, and plane figure. The center of gravity can be defined as the point through which that entire the weight of the object is supposed to act. So first of all, we have to look at the center of gravity of the regular objects such as hemisphere, cylinders, right circular cone, and solid cone, and so on. The main difference between the plane figure and solid body is that in the case of solid bodies, calculate the volumes instead of areas. Volume of the cylinder, it is given by pi r square h. Volume of the hemisphere equal to 2 by 3 pi r cube. Volume of the right circular cone, it is equal to 1 by 3 pi r square h, where r is representing the radius of the body, h is equal to height of the body. Sometimes the density of the two bodies are different. In such cases, calculate the weight instead of volumes, and the center of gravity is determined as well from the fundamentals. Here the composite figure we are taking, determine the center of gravity of this figure. It is a three-dimensional object now. A solid body formed by joining the base of right circular cone of height h to equal base of right circular cylinder of height a to h as shown in figure. Calculate the distance of the center of mass of the solid from its plane base when capital H is equal to 120 mm and small h is equal to 30 mm. Here, when I am dividing this object into two objects, the first one is the base, it is given now at the bottom, it is in the form of cylinder, which is having radius is equal to r and height is equal to 30 mm. Above the cylinder, right circular cone is fitted over it, which is having the base diameter is equal to the diameter of the cylinder and height is equal to 120 mm is given now. Since the object is symmetrical about the vertical lines, hence this symmetrical line is treated as a y-axis in which the x coordinates of the center is equal to 0. Similarly, the y value, it can be determined separately with respect to the bottom lines for object 1, similarly for the object 2, which are here taken as y1 and y2 now. Now, on doing the calculations, v1 is equal to the volume of the cylinder is equal to pi r square into h. It is equal to h is equal to 30. It can be written as 30 into pi into r square. And y is equal to y1, it is equal to 30 by 2, which is equal to 15 mm. For right circular cone, v1 is equal to 1 by 3 pi r square h, which is equal to pi by 3 r square, which is equal to 120 mm, 40 pi r square mm cube. And y2 is equal to, here according to this figure I am taking now, here if it is A, it is a B, and somewhere it is C there, we can write it as AB plus BC by 4 now. So which is equal to 30 mm plus 120 mm by 4, which is equal to 60 mm. Just it is giving the values of y2. The distance between center of gravity of the section and the base is equal to, since both the objects are made up of same materials, hence the density is a constant, we can take it as base is equal to v1 y1 plus v2 y2 divided by v1 plus v2, which is equal to, and substituting the values of v1 y1 plus v2 y2, we got 30 pi r square into 15 plus 40 pi r square into 60 divided by 30 pi r square plus 40 pi r square now. Since pi r square is the common words, on doing the remaining calculations, we got to 2850 divided by 70, which is equal to 40.7 mm. That means the center of gravity of the whole figure, it lies at a distance of 40.7 from its base. Somewhere it is located at this position. Assume this is the position of center of gravity. Okay, second problem. A body consists of a right circular solid, cone of height 40 mm and radius 30 mm, placed on a solid hemisphere of radius 30 mm of a same materials. Find the position of center of gravity of the body. A body consists of right circular solid cone. Here it is represented as A, B, C now, which is placed on a solid hemisphere, which is represented as here now A, D, B and so on. Find the position of the center of gravity of the body now. Since it is made up of same materials, it's not at all required to take the weight of the body now. That volume is enough now. And on observing this figure, this object is now symmetrically with respect to the vertical line. Hence, this symmetrical line is treated as y-axis. Hence, while calculating center of gravity, the determination of x coordinate is not required now. Now, the bottom line, which is passing through point D, is treated as now x-axis now. Now, the position of y1, it is equal to, for the first object now, that is the hemisphere now, it is equal to 5r by 8. So, it is equal to 5 into 30 divided by 8, which is equal to 18.75. Similarly, for the right circular cone, Bt is equal to 1/3 pi r square h, which is equal to 12,000 pi m cube, and Yt is equal to, here height is given, that is D, as in just E is given, that is dA plus EC divided by 4, that is h by 4 now. That means 30 plus 40 by 4, which is equal to 40 mm. So the distance between the center of gravity of the body and bottom of the hemisphere is equal to Yc equal to V1 Y1 plus V2 Y2 divided by V1 plus V2. So on substituting the values of V1 Y1 in these equations, we got 18,000 pi plus 18,000 pi into 18.75 plus 12,000 into 40 divided by 18,000 pi plus 12,000 pi. On simplification, we got 27.3 mm. This is the position of the center of gravity of the given composite object. Similarly, the problem number 6, one more, a right circular cylinder of 12 diameter, 120 mm diameter, with a hemisphere of the same diameter face to face. A right circular cylinder of 120 mm diameter is joined with a hemisphere of the same diameter of face to face. Find the greatest height of the cylinder so that the center of gravity of the composite sections coincides with the plane of the joining two sections. The density of the material of the hemisphere is twice that of the material of the cylinder. So, as the body is symmetrical about the vertical axis now, hence the center of gravity of this composite figure lies on this line, not required to determine the x coordinate. Now, for the composite figure now, h is representing height of the cylinder in mm, and 60 mm is, and we are considering the dimensions of right circular cylinder. Having weight is equal to W1 because they are now made up of different materials. Assume ρ1 is representing the density of the cylinder. So rho 1 into pi by 4 d square h. So which is equal to 3600 rho 1 pi into h. Similarly, y1 is equal to, we can take it as 60 from bottom position now, which is passing through point P. We are marrying 60 plus h by 2, which is shown in figure 2 now. Similarly, for the hemisphere now, the density material is assumed it is rho 2, 2 by 3 r cube, which is equal to 2,88,000 rho 1 pi, because rho t is equal to 2 into rho 1 according to the problems. The density of the hemisphere is the half of the density of the right circular cylinder, and yt is equal to 5r by 8 from the base P, which is equal to 37.5 now. So the distance between the central gravity of the combined figure is given by yc is equal to w1 y1 plus w2 y2 divided by w1 plus w2. Since the density is not the same for the two bodies now, hence we are taking in terms of their weight now. So on simplifications we got, since not stable means that should be constant with the O point, that is 60 is required now. So on doing the calculations we got h is equal to 60 mm in order to keep it in, that is in order to keep the central gravity of the composite section constant with the plane of the joining two sections. Now for the plane figures, if it is in a curved form, the integration method is preferable now. Now determine the coordinates of the CG of the area OAB is shown in figure. If the curve OB is representing the equation of a parabola given by y is equal to k square, in which OA is equal to 6 units and AB is equal to 4 units. The equation of the parabola is given here as y is equal to kx square. It is equation number 1. First of all, we have to determine the value of k in terms of its coordinates, x coordinate and y coordinate, the plane figure. At a point B, the coordinates of point B are now 6, 4. On substituting in the equations y is equal to kx square, we got to k is equal to 1 by 9 now. Substitute the values of k in the equation number 1. The equation of the parabola can be written as now x square ky or x square equal to 9y or x is equal to under root of 3 into under root of y, which is shown in figure equation 3rd now. Now consider strip of 8y and width dx as shown in figure to determine the central gravity of the plane figure, which is having infinitesimally thickness dx as shown in figure now. At a distance of x from the vertical line. Here, since the object is not at all symmetrical with respect to the vertical and horizontal lines, hence the x-axis is treated as the line which is passing through the bottom of the figure, and the y-axis is the extreme left position now, which is passing through point O now. Now considering that strip which is having thickness is called dx at a distance of x, the central gravity of the strip is represented as x, that is x coordinate, and y coordinate is nothing but half of its height. It is given by y by 2 now, where x star and y star is representing the coordinates of the assumed strip which is at a distance of x. The area of the strip is given by y into dx, that y is representing height, dx is representing its thickness now. The coordinates of CG of this area is given by x and y2. The distance of the CG of the area dA from the y-axis is equal to x, because we are considering its thickness is infinitesimally small, and the y-axis it is at the distance of y by 2. These are now represented as the x star is equal to x, so y star is equal to y by 2. Now xc is the representing the distance of CG of the area OAB from the y-axis. Similarly, yc is representing the distance of CG of the total area OAB from the x-axis as shown in figure. Now using the equations, we got xc is equal to, according to the integration method, from 0 to 6 x into dA divided by dA, which is equal to, x star is equal to, already we have taken x, it can be written as 0 to x integration xy dx divided by 0 integration of 0 to x by dx. So on simplification, we got x into dA is equal to 1 by 9 x square dx divided by 0 to integration of 0 to x 1 by 9 x square dx. On applying this, after doing integrations and applying integration limits, we got xc is equal to 4.5 units. Similarly, yc is equal to 0 to 6 y star dA divided by integration of dA, which is equal to, y star is given by y square by 2, y by 2, which is equal to y by 2 into y dx. Since y square is equal to, y is equal to, which is equal to integration of y square by 2 into dx. Okay, on simplifications, this we got this yc value now. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.